Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. We are discussing NCERT Science textbook of class 10, where we are carrying out discussion of individual chapters. The agenda for today's discussion is chapter 14, that is sources of energy. I would say this would be a relatively easier discussion because now we have entered into the domain of environmental topics. Before this, from chapter 1 to chapter 5, we have discussed topics connected to chemistry. From 6 to 9, we have discussed topics connected to biology. And from 10 to 13, we have discussed topics which are connected to physics. Today, we are going to discuss chapter 14, sources of energy. I would be discussing this from a very generic point of view, where we will be focusing on understanding more and more about production of electricity using different sources of energy. We'll talk about conventional sources of energy, non-conventional sources of energy. I'll be explaining you about how we generate electricity predominantly. And for that, I want you to remember a few things from chapter 13. I hope you have seen our latest interaction, magnetic effects of electric current, where we discussed the concept of electric generators. Do you remember it? In this chapter, we discussed that when electric current is passed through a conductor, it leads to creation of a magnetic field. We understood that, and one of the applications of that was electric motor. How did we do it? We said that because of a magnetic field, the conductor or the electric wire, it sees some sort of movement. And when we reverse that concept, meaning when I have movement in the conductor, can I induce EMF? Can I induce electric current in it? Yes, that is called as electromagnetic induction. We have seen it. Now, do remember that particular concept because we will be discussing sources of energy from that point of view itself. Right. Let's begin our interaction. Sources of energy. Now, we use different sources of energy. For all of us, the ultimate source of energy is sun. Now, from sun itself, we use many other sources of energy that we have here. The ultimate source is that here we may use, say, fossil fuels. Somebody may use firewood. These days we have LPG at our home. I use petrol in my vehicle. I use diesel in my car. So I have different kinds of fuels that I use as a source of energy. Now, when we talk about energy, there are some parameters which makes a source a good source of energy. And how do we assess that? Any source of energy, if it releases good amount of heat when it is burnt, it becomes a good source. It should give heat because that is my ultimate requirement. I need heat, say, for cooking. I need heat for my IC engine, internal combustion engine, to run. I need heat so that I transform water into steam. I use that steam for generating electricity. So it needs to produce heat. How much smoke does it produce? Now, I want it to produce less amount of smoke because I don't want that source of energy to ultimately lead to pollution. Apart from that, how easily is it available? Meaning, if I have a source of energy, say, deep inside the oceans, now extracting that itself becomes a huge problem. Will it be financially viable for me? It may not be. So it should be easily available. That is why people during the ancient and medieval times, they used firewood a lot because it was very easily available. Simply dry it and you can use it for your heating requirements. But slowly and steadily, we came into the modern era. We started using coal. We started extracting petroleum. We use natural gas now. Today, in 21st century, we talk about the concept of climate change, global warming, and we want pollution to go down. We want greenhouse gases to go down. For that, we are looking towards more cleaner and greener fuels. That means more cleaner and greener sources of energy. So what would make a good source of energy? If, first of all, that source of energy should be sustainable, meaning I can use it for a long time. It must be a renewable source of energy. It should be clean source of energy. It should have high calorific value, meaning if I simply burn 1 kg of that fuel, that source of energy, it should give me proper amount of heat, whatever is needed. It should be easily accessible. It should be easily accessible. Extracting that should be quite easy. And it should not cause pollution. This is one of the important parameters. Apart from that, we also talk about ease of transportation, right? It being economical, all these aspects also make a good source of energy. Now, in general, whenever we talk about energy, we divide energy into two broad categories: conventional sources and non-conventional sources. Now, by the term itself, conventional, meaning which we have been using from a very long time. Say, for instance, we have fossil fuels. We use fossil fuels almost from 200, 300 years. From the time we understood or we discovered the utility of coal, we have been using it. Now, before that, firewood is another natural source, again a conventional source I can call, which leads to a lot of pollution, yes. But from modern times, we use fossil fuel based energy sources. Predominantly, I have coal. Later on, I also discovered petroleum. Now, by fractional distillation of petroleum, I created gasoline, that is petrol. I created diesel. I created other fuels, kerosene, etc. Right now, in recent times, we are talking about natural gas. This is also fossil fuel. All right, fossil fuel means a source of energy which takes a very long time to replenish itself. So conventional sources, I can also call them in an analogous way as non-renewable forms of energy, meaning it takes a very long time, it takes centuries together for them to be replenished. On the other hand, we also categorize broadly as non-conventional sources. Now, non-conventional sources are the ones which I would say largely they are renewable. They are more cleaner, they are more greener as well. Examples being solar energy, wind energy, tidal energy, geothermal energy. These days, many people talk about nuclear energy also as non-conventional source, but nuclear energy has its own threats, has its own issues. We can give example of Chernobyl, we can talk about Fukushima, etc., because it may lead to some sort of radiation based threats. All right. So this is how we categorize. Now let's look at how we use these fuels, to produce electricity, because our main discussion is to understand different kinds of power plants. Now today we talk about power plants which are based on fossil fuel, predominantly on coal. We talk about power plants which are based on diesel. We have power plants uh, which are based on water. Those are hydroelectric power plants. These days, we talk about solar power plants. We talk about nuclear power plants. We talk about wind turbines, wind-based power plants. So we'll talk about these one by one. First, we understood the conventional source of energy, predominantly fossil fuel based, coal, petroleum, natural gas. Now, this power plant can be natural gas based also, right? Now, what would be the working of a simple thermal power plant? Here, when I say thermal power plant, I would say this, or I would write it as fossil fuel based power plant, meaning I will be burning fossil fuel. Once I burn fossil fuel, I will be heating one equipment. And what is that? I would be heating water. Now, once I heat water, I would turn this water into steam. And this steam is now focused through a nozzle or propelled onto this turbine. Now, this turbine rotates. I give you an example of Swadeshi. I hope you remember from the last class. I told you, what does Shah Rukh Khan do? Shah Rukh Khan has created a reservoir. He opens the valve, the water moves. Now, instead of water, think a very high speed jet of steam is coming and it is rotating this turbine. And I told you, how does the electric generator work? This turbine moves. Once this turbine rotates, this is the rotor. So in this generator, there is a rotor coil. Let me just change the color. There is a rotor coil. Oh, okay. Black color. There is a rotor coil and then there is a stator coil. Now, once the rotor coil rotates, the rotor coil, because of its magnetic effects, it is going to induce current in the stator coil. And that stator coil's current, it can be passed through a transformer, step up transformer, step down transformer, whatever it may be, sent to the transmission line. Generally, when we use transformer here nearby the generating station, those are step up transformers. And I told you why. Because step up transformers, they increase the voltage manifold. When I transport energy or when I transport electricity in high tension lines or high voltage lines, power loss would be reduced. All right, that means high voltage, low current electricity is passed here. Once it reaches my place, my substation, then I use step down transformer. The voltage is reduced, proper current can be supplied to me. Now, this is how the thermal power plants work. Now this particular fuel, it can be coal, it can be, I would say, diesel, it can be natural gas based power plant. These are fossil fuel based conventional ones. Now among this conventional itself, these days we have made improvement in the conventional sources of energy. One of the examples being that we are generating biogas. Now biogas is generated from what? Biogas is generated from biodegradable waste. Biodegradable waste, for example, biodegradable waste, the waste vegetables, the waste organic material, the waste food articles, right? What happens to it? We use these waste material, we put them in a digester, and there it undergoes anaerobic decomposition, and ultimately this biogas forms, and we use this gas outlet, and you can use this as fuel. Mostly it comes as methane. Basically methane gas is seen here, so methane can be used here. Now when I use this methane in a power plant, now imagine I take this, I use this particular gas, I burn this gas, I boil the water, I get steam. Using that steam, I run the turbine, I run the generator again through the transmission line. Now this becomes a biogas based power plant. All right. So majority of our power as of now, it comes from the conventional energy sources only. In India, more than 50% of electricity that is generated, it comes from coal based power plants even till today. If you want to get the latest numbers, you can always go to the website of MNRE, Ministry of New and Renewable Energy website. There you will get all the details about the latest renewable projects and what is the energy mix of a country as of today itself. All right. So whenever you have your exam, just before the exam, do visit the website so that you get some accurate numbers which you can mention in your mains answer writing as well. All right. So this is about the conventional sources. We also have non-conventional sources. Now many experts put hydroelectric power in conventional itself, but I would say again it is largely renewable source of energy. But let's try to understand how it works. Now this is the classic example which I gave from a movie, from Swades. Now what Shah Rukh Khan does, he has created a small reservoir. And from this reservoir the water will enter through a penstock. This is called a penstock. From that the water will enter. The water at high pressure, very similar to how a nozzle effect works. That high speed water, it comes and it runs the turbine. The turbine, it rotates. Now once the turbine rotates, that rotation is used. That rotor acts as a primary coil. The secondary coil is nothing but the stator. Electricity is generated. Again, that electricity is transmitted through the transmission lines. That's the basic idea. Now everywhere you are looking at the same thing. Now you're thinking, sir, why can't I create only hydroelectric power plants everywhere? Is it not possible? Yes, it is possible. But again, for hydroelectric power plant, you need availability of water for 365 days. You do understand how electricity reaches your place, right? If you have a misconception that electricity is stored somewhere and then it comes to you, that is wrong, because it would become physically impossible. Imagine that I have to provide electricity to crores of people. Where will you store it? We do not have that battery technology. So that's why what the generating companies do. Yeah, let me just give you some idea about that. The generating companies, they have the data of the demand. They do know that yearly the demand fluctuates. For instance, during the summer season, the electricity demand goes very high because of the cooling needs. So generating companies, what they do, they have a schedule. They have a schedule of running their generators. Once the electricity is generated continuously, it would be transmitted through the transmission based company, through the transmission lines, and then ultimately these are the discoms at your place, the distribution companies, they supply to your home. It's not like it is stored somewhere in a battery and then it comes to you. No, meaning these generating companies, they have to run at a very tight schedule according to demand, and that demand, they do have an estimation of that. Sometimes when the demand fluctuates, when it is extremely high, you see a lot of load shedding. Now you normally see load shedding at your place during the summer season. Why? Non-availability of water wherever it is coming from the hydroelectric power plants. Clear? Right. Let's talk about some other ideas. Solar power plant. Now this is again a non-conventional way of generating electricity. These days, solar power plant has gained a lot of traction because the government is running National Solar Mission, which has very stiff and ambitious targets. Slowly and steadily, we are reaching towards it, although the 2022 target of 100 gigawatt has not been achieved. We have fallen short approximately by 20%, 20 to 25% there. Still, it's a good achievement that we are creating, or we are going for more and more solar projects. Now, how does a solar power plant work? Now, solar power plant, we create an array or a grid of solar photovoltaic cells. These are photovoltaic cells. These are photovoltaic cells. Now, once sunlight falls on these photovoltaic cells, they convert this solar energy into electricity, which I can use through this inverter technology, and I can connect it with grid. And this is the biggest problem that we face right now. And for this, Germany is helping India how to connect it with main grid. How to connect that with main grid, because you do know, if I'm using a conventional source of energy, coal-based power plant, it will run at optimum load. It will run at optimum load. But what happens with this solar light is, during the daytime it is actively working. During the daytime it is actively working, and it is producing that electricity. It is producing electricity because of the working of photovoltaic cell, and that I can connect to grid. And in many solar-based power plants, you might also find some sort of battery banks, probably to use them when the sunlight is not available, or provide energy when electricity when sunlight is not available. All right. So we have connected many of the solar plants with our main grid right now. All right. Right. So this is the solar power plant. Apart from that, we also have wind-based power plants or wind energy. Now, wind energy means I use the concept of air moving from one place to another place. Wind. All right. So air moves from a point of high pressure to low pressure. I use that movement to propel this wind turbine, and this wind turbine has huge blades. They are aerodynamically designed such that this wind will make these blades rotate. This fan would be rotating. You must have seen it at many places while traveling, etc. Of great heights. These wind turbines are of great height, and you must be feeling, sir, I have seen that these wind turbine, these fans, they rotate at a very slow speed. Then how does it generate electricity? Now, please remember, they have different kind of gearing systems, because of which this low speed of these fans is now transformed into high speed rotor. And again, the same concept of generator works, and the generator generates electricity, and that is connected to your electric line through the transformers. Same idea. Apart from this, we are also using some other non-conventional energy sources like geothermal energy. Now, geothermal energy, you do know that if we go deep inside the earth, you will see that the temperature, as we go towards the center of earth, it continuously increases. That means below we have more temperature, higher temperature, and this high temperature, we use that temperature to capture or to get that hot water. Geothermal energy means hot water coming from underneath, coming from beneath. We use it so that we reduce our input cost here, and here we convert that to steam by maybe putting in some other kind of energy, maybe fossil fuel based energy, etc. But right now this is relatively hotter. I would need lesser amount of energy to transform it into steam. Then I use the steam to run the turbine, generate electricity, then use it with the grids. There are many geothermal power plants which are in the testing phase. There is a geothermal power plant in Ladakh. So keep a track of these. Wherever new geothermal plants are coming, keep a track of those things. All right. Now, apart from this, we also use tidal power plant. Now, this is again a renewable source of energy, a non-conventional source of energy. Because of the gravity of earth, and because of gravity of moon, and the gravitational power of sun, we get different kinds of tides. Now, whenever there is a low tide, the water recedes. And whenever there is a high tide, the water level rises. Now, we use this particular concept and create some sort of a barrage. This is the ocean level. This is the barrage level. Whenever there is a low tide, we see that the level of water in this barrage is low. So we cannot generate electricity at that time. But whenever there is high tide, the water level is this. And at this point, what we do is we open the sluice gate, or we open the barrage. And once this opens, the turbine rotates. The rotor rotates, and this rotor, it is connected above to the generator, which generates the electricity. So these kind of experimental tidal power plants are also quite active, especially along many coastal locations. Keep a track of these as well from your current affairs preparation. All right. So different sources of energy, conventional, non-conventional. We discussed many ideas. The last idea here is the nuclear power plant. Nuclear power plant, instead of using a fossil fuel, nuclear power plant, it uses nuclear fuel. Now, nuclear fuel, as of now, what we use is, we use uranium-235. Now, uranium-235 or uranium oxide, it is enriched according to the nuclear power plant level, and it is used as a core. And this uranium is bombarded with high energy neutrons. What will happen? Uranium nucleus will break. And once this nucleus breaks, it gives you huge amount of energy, leading to formation of other fragments, other elements. Along with it, energy is released. Other neutrons are also released. And these neutrons can sustain nuclear fission reaction. Please remember, whatever nuclear power plants we have, they are all fission reactors. Fusion technology is not yet active anywhere in the world. It is only experimental. There are many experiments which are running in China, in UK, even in India. We have Aditya Tokamak in Ahmedabad, in Gujarat. Testing is going on, but nuclear fusion based reactors are not operational anywhere at the commercial level. Please note this. Everywhere in the world, there is only nuclear fission technology. Because of this nuclear fission, we extract heat out of this. Using this heat, we transform water into steam. I use this steam to run the turbine. This turbine rotor, it generates the electricity, and the same can be connected with the grid. That's the basic idea of nuclear power plant. All right. The source here, the only source of heat is changing. If I use coal here, that becomes a coal-based power plant. If I use diesel, it becomes a diesel-based power plant. If I use nuclear energy here to transform water into steam and then to run the turbine, it becomes nuclear power plant. We have many nuclear power plants. More than 20 nuclear power plants are active in India. The latest ones that are active in Kudanakulam in Tamil Nadu. Different nuclear power projects are already active, which are in collaboration with Russia. There are many power plants which are in building stage right now. There are some coming up in Maharashtra. There is one coming in Gujarat. So keep a track of all these from your current affairs as well. And whenever those power plants are active, make a note of that. All right. So this is a discussion about different sources of power. We discussed conventional as well as non-conventional. Before I leave, I have to put in a notice that for all the UPSC civil services aspirants, prelims to interview initiative is being offered in 3 formats: English, Hindi, and in a bilingual format. The batch is starting from 11th August at 8 a.m. Do not miss this out, because this would be one of the last batches that we are offering for P2I for the year 2024. If you clear your preliminary examination, you would be called to StudyIQ Center, where you would be spending almost 100 days with faculties and the mentors to hone your answer writing skills without any additional cost. This is the cost of the entire program. Your boarding, lodging, everything in the mains registration program, it would be taken care of by StudyIQ itself. So enroll for this program. I'll see you in the class. And if you have any queries, any doubts, you can always reach out to me on this particular ID at the rate Rahul Sai 22. Thank you again. Jai Hind.